I'm going to list our 6 pupils, and here is one way of allocating the medals. I could have gold, gold, maybe then bronze, then silver, gold, and then silver again. What we're interested in is how many different ways we could arrange these medals. Now, if you have something like A, B, C, D, and asked how many different ways, the answer is actually 4 factorial, because there's 4 ways to pick the first letter, then 3 ways, then 2 ways, and 1 way, because we're not allowing any repeats here. So this will be 24. Now, if you had something like A, C, D, then it would become 4 factorial, but now for every arrangement, you could swap these two around. So you have to divide by 2 because we've double counted. In fact, sometimes we say that we divide by 2 factorial because there's a little kind of pattern that then follows, which I'm now going to apply here. We've got 6 factorial because I'm arranging 6 different things. I'm going to divide by 2 factorial because every time I swap the silvers around, it doesn't make any difference. But now I can also arrange the golds in 3 factorial different ways. Imagine however I've arranged them, I've got G1, G2, G3 in some order. There's 3 factorial ways of arranging these, 3 times 2 times 1. So this is what I'm trying to work out. And it becomes 6 times 5 times 4 times 3 times 2 times 1, but I could just write 3 factorial here. The reason being is that I can just cancel them out now. I can also cancel that 2 out with the 4. 5 times 2 is 10, 6 times 10 is 60, and that is our answer. If this topic is new to you, then I recommend looking into it a bit more. It's called arrangements or combinatorics. I'll write that down. And there's a lot to it, and there's lots of interesting problems out there to investigate. And the thing is, they're all quite different, so it does require a bit of time, but stick with it. Just going to go through this question in a different way now. This is how the solutions do it. It's quite good. Rather than writing them down, um, and then just thinking of arranging the objects, we're going to apply the medals and look at in how many different ways we can actually apply the medals. So if I pick bronze first, then there are 6 people that I could give it to. And then if I pick the silver, there are 5 ways. And I would multiply these together because for the 6 different ways that I can apply the bronze, I can then apply the silver in a different way. It's a little bit like when you have 3 t-shirts and 2 pairs of shorts. Well, you could give somebody a pair of shorts and then there's 3 different t-shirts you could give them. Or you could give the other pair of shorts and then there's another 3 t-shirts you could give them. It's the same idea here. If we now apply the second silver medal, then there's 4 people. But if we were to swap these 2 around, we'd get the same thing. So we actually are going to have to divide by 2 at the end. We've double counted. And then for the golds, well, I can apply these now. It's going to be 3 times 2 times 1, but actually it doesn't really matter. The remaining 3 people are all going to get golds. So in fact, I can just ignore this. Previously, I would have times by 3 times 2 times 1 and then divided by 3 factorial, but the outcome is that we just times by 1. And again, we can cancel these out to give 60. So yeah, quite like that approach, different way to think about it.